Today we are graphing absolute value graphs again, but today's lesson I'm going to do differently than I did the previous lesson, and the reason I get to is because in all of the problems today, our m value is going to be 1. So if your m value is 1, then we can do all of these different translations that I'm going to talk to you about. So just to show you that the m is a 1. Do you remember that in the last lesson that we had this formula for our absolute value graphs? And remember that m is inside the absolute value bars, smushed with the x. So when you look at this problem here, inside the absolute value bars smushed with the x, you don't see anything. That means m is 1. In this problem, inside the absolute value bars, smushed with the x, you don't see anything. So m is 1. In this problem, inside the absolute value bars, in front of the x, you don't see anything. So m is 1. So if your m is a 1, then you get to do these translation rules. If your m is not a 1, then you have to use this formula from the last lesson to find your vertex. Okay? So, last lesson, in this one, our m was not a 1, so we had to use this formula. Okay? All right. Up here, this is just telling you that if it's a positive in front of the absolute value bar, that the graph opens up, but if it's a negative in front, the graph opens down. Just to show you the last lesson, that's exactly what happened. When the number in front was positive, making a positive slope value, the graph opened up. But when the number in front was negative, making a negative slope value, the graph opened down. Okay? All right, so let's learn what we get to do if the m is a 1. So the first two translation rules are really easy. If you see a number on the outside, it moves your graph up when it's a plus, and it moves your graph down if it's a minus. All right, so first I'm going to try to write some equations. All right, so this is telling you to write an equation for the translation of this parent function, y equals absolute value of x. So what I want to do is I want to take this graph 8 units down. Okay, if I want to take something up or down, then I know I have to put the number behind the absolute value bars. So absolute value of x will stay just like that. And to make something go down, I use a minus sign. So it's going to say minus 8 in the back. And that would make, this equation would make this graph go down 8. Okay. If I had, I should have my graphing calculator so I can prove it to you, but I don't have it on me right now. I have my phone calculator. I can try that real quick. Let's see if we can see it. So y equals absolute value of x, and then the new equation we just wrote was absolute value of x with a minus 8 in the back. Okay, so what I'm saying it's going to do is take the graph down 8. Let's look. There's the original, and oh, we can't see it because of the scale. Let's see if I can change the scale so you can see it. Sure enough, here's the original, and then the other one took it down 8 units. Okay, so this next one here, if I wanted to take it up 6, remember up or down, the number goes in the back. So I'm going to keep the absolute value of x, and to make it go up, I use a plus. And then let's try it going down 2. Remember up or down, you put the number in the back. So absolute value of x, and to make it go down 2, it's going to say minus 2. So if it's a minus in the back, it goes down, but if it's a plus in the back, it goes up. All right, now I only get to do these fancy rules. Remember, if your m is a 1. And we already talked about all of these m's or 1s. So we just need to know, what does the -1 in the back do? It makes your graph go down 1. So one thing that you're probably not aware of, but the parent function always has its vertex at 0, 0. Okay? So I'm going to go to 0, 0, and then this says take it down 1. So down 1. Now I need to know what my slope is. And do you remember slope is anything smushed with the x? So who do you think the slope is? 1. You don't see anything smushed with the x. That means that it's a 1. So that's understood to be 1 over 1. So up 1, right 1, up 1, right 1, up 1, right 1, and then reverse it. Go back to your vertex, go up 1, but left 1, up 1, left 1, up 1, left 1. And now make your V, arrows on both ends. I won't have us practice domain and range today. It'd be always good to practice it, but I was trying to make this lesson a little bit faster. All right, let's look at number 5. Okay, so what do you think the +4 in the back is going to make your graph do? Go up 4. So instead of starting at 0, 0, I'm going to go up 4. 1, 2, 3, 4. Now I need to know something about my slope. And remember, slope is anything smushed with the x. So who do you think slope is? 2. And remember, that's the same thing as 2 over 1. So from my vertex, I'm going to go up 2 and right 1. Up 2 and right 1. Now let's get the other half. Go back to your vertex. Go up 2, but left 1. Up 2, left 1. Make your V, arrows on both ends. And there's our graph. Okay, this one here. What do you think the -3 in the back is going to make the graph do? Go down 3. Okay, so instead of the absolute value starting at 0, 0, it goes down 3. Now we just need to figure out our slope. And who do you think the slope is? -4. The slope is anything smushed with the x. And remember, -4 is the same thing as -4 over 1. So we're going to go down, but right. Because if the bottom number is positive, you go right. So down 4 and right 1. I don't have room to do it again, so I'm going to go back to the vertex, go down 4, but this time left 1. Now I can make my V, arrows on both ends. Now remember, the only reason I am not having to use this formula from the other day, opposite of B over M comma C, is because my M values are all 1s. Okay? All right, let's look at the next page. All right, we have 2 other translation rules, but these are always confusing to students. This time we see something happening inside the absolute value bars. Something happening inside is left or right. So this is weird. If you see a plus inside, you go left. If you see a minus inside, you go right. And that's going to be backwards to your natural thought. Okay, so it's something you have to train your brain to remember. Plus inside makes you go left. Minus inside makes you go right. Whereas we just learned that in the back, plus outside in the back is up, minus outside in the back is down. Now that makes sense mentally, but this is flippity-flop. So plus inside is left, minus inside is right. So it's opposite land. All right, so if I want to make my graph go left or right, remember left or right, you put it in the absolute value bars. So I'm going to keep my x inside the absolute value bars, but I'm going to have something else in here. And what do you think it's going to be? Plus 7. To make it go left, you use a plus. So plus 7. Now, let me just show you that that's what it actually does. Okay, so I'm just going to use my phone because I forgot to bring my calculator. All right, so I'm going to have the y equals absolute value of x. And then this one, I need to change that. On the inside, it's going to say +7. Okay, so I have x plus 7 inside the absolute value bars. All right, so let's graph it and see. And so here's our original parent with the vertex at 0, 0, and look which way it went. It went left. And that's exactly what we said. We wanted it to go left 7. And that's exactly what it did. Okay. So kind of strange at first. So this time I want it to go right. So if I want it to go right, then right is a minus. So -5. And I could graph it and make sure that that actually makes sense and it actually works. That's what exactly happens. Okay, let's try it again. Left and right take a little more thought. So left and right, remember it's always going to be inside and opposite of your natural thought. So to make something go left, I use a plus. So to make it go 0.7 left, I put plus 0.7. And then this one, I want to make it go right. So to make it go right, I'm going to use a minus. So -7/3. And that's my answer, and I'm done. Okay, now we're going to actually graph them. So first, let's look. Are our m's 1s? Yep. Smushed with the x inside the absolute value bars. You don't see anything, so it's a 1. Inside the absolute value bars, smushed with the x, you don't see anything, so the m's a 1. And inside the absolute value bars, smushed with the x, you don't see anything, so m is a 1. All right, these translation rules only work if m is 1. And remember, if m is not a 1, we have to use this formula from the previous lesson. Okay? Now, just so you know, I could use this formula on this lesson too, but it takes longer. So I wanted a lesson that goes quicker. So that's why we're practicing our translation rules. All right, so what do you think the plus inside makes you do? Plus inside makes you go left. So I go left 2. All right, so instead of my vertex being at 0, 0, I go left 2. Choop, choop. Now, what do you think slope is? Slope is 1. Slope is anything smushed with the x and you don't see anything, so it's a 1. Or 1/1. So that's up 1, right 1, up 1, right 1, up 1, right 1. Now let's get the other side of the V. Go back to your vertex, up 1, left 1, up 1, left 1, up 1, left 1. And let's make our V. Arrows on both ends. Ooh, I didn't draw that one very well. Oh well. Okay, looking at number 6. What do you think the minus inside makes you do? Okay, minus inside makes you go to the right. So this is going to make us go right 4. So instead of starting at 0, 0, I go right 4. 1, 2, 3, 4. Now, what do you think the slope is? -1. The slope is anything smushed with the x, and it's a -1 because you don't see the number there. Remember, every number is understood to be over a +1. So we'll go down, but we'll go right. So from the vertex, down 1, right 1, down 1, right 1, down 1, right 1. To get the other half of the V, go back to the vertex, down 1, left 1, down 1, left 1, down 1, left 1. Arrows on both ends of your V. Okay, and let's look at number 7. So what do you think the -2 inside is going to make you do? It's going to make you go right. Remember, minus inside makes you go right. So right 2. So from 0, 0, I go right 2. Now let's deal with slope. And who is slope? -3. Slope is anything smushed with the x. And remember, every number is understood to be over a +1. So what's that telling us to do? Go down 3, choo, 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 and right 1. Do it again. Down 3, choo, 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 and right 1. Let's get the other half. Down 3, left 1. Down 3, left 1. Let's make our V. Arrows on both ends. Okay. Essentially, that's the lesson. We're just going to keep practicing, and now we're going to practice both the movements up, down, left, right together. Okay, so let's remember. Plus in the back makes it go up. Minus in the back makes it go down. Plus inside makes it go left. Minus inside makes it go right. Okay, so I want to write an equation to translate this parent function. Okay, so I'm going to put that x in there. Okay, if you want your graph to go up 2, will that be inside or outside? Outside. Remember, up and down is outside. And to make it go up, we use a plus. And then to make something go right, that goes inside, and it's a minus. So minus 3/2. That's our equation, and we're done. All right, this one. Let's get y equals, let's go ahead and get our x in there. All right, so this one, we want to take it 3 down. Is that inside or outside? Outside, and it's going to say minus 3. Inside, to make it go left, what do we use? A plus. And we want it to go left 7.5, so it's going to say plus 7.5. And that's our equation, and we're done. Okay, number 3. Okay, let me get my equation started. Y equals the absolute value of x. So to make it go 1/2 down, is that inside or outside? Outside, and it's going to be minus 1/2. And to make it go right, it's going to be inside with the minus. Okay, let's try graphing some of these. Okay, here we go. So remember, this only works if your m is a 1. Does it look like m is a 1 in all these problems? Yep. Remember, m is inside the absolute value bar, smushed with the x, and if you don't see anything there, it's a 1. That 5 is not the m. That 5 has to do with slope, not the m. Okay, so let's practice our movements. What do you think the plus 2 inside makes you do? Makes you go left 2. What about the minus 1 in the back? Down 1. Okay, just to remind you, the plus inside makes you go left, and the minus outside makes you go down. All right, so let's do what we said. From 0, 0, let's go left 2, 2, 2, and down 1. Now, who's our slope? Our slope is 1 because we don't see anything smushed with the x, so that means the slope's a 1. And 1's the same thing as 1 over 1. So it's up 1, right 1, up 1, right 1, up 1, right 1. To get the other half of the V, go back to your vertex. Up 1, left 1, up 1, left 1, up 1, left 1. Now let's make our V. Arrows on both ends. What do you think? Do you kind of like this lesson? Lots of kids like it, and then there's a lot of kids that don't. You never know. It just depends on you. I have had lots of students in the past that prefer this formula to having to remember left, right, up, down. So it just depends on you. Okay, let's keep practicing. What do you think the minus 3 inside is going to make you do? It's going to make you go right 3. What about the plus 2 in the back? Up 2. And if you don't remember, you can always go back and look. Minus inside is right, which is what we said, and plus in the back is up. All right, so let's do it. From 0, 0, go right 3, 2, 2, 2, and up 2. Bink, bink. Now we just need to know slope. And who is the slope? The 5. Slope is anything smushed with the x, inside, outside, or both. And remember, every number is understood to be over a positive 1. So from our vertex, up 5 and right 1. I don't have room to do it again, so let's go back to the vertex and go up 5, but left 1. Make your V, arrows on both ends. Okay, let's just look at number 7 here. what do you think the plus 4 inside is going to make you do? Left 4. And what about the plus 4 in the back? Up 4. Okay, so let's just do that. From 0, 0, go left 4 and up 4. And now, what do you think the slope is? -2. Slope is anything smushed with the x. And remember, every number is understood to be over a positive 1. So how do we graph that? What do we do? Down 2, right 1. Down 2, right 1. Okay, go back to your vertex. Down 2, left 1. Down 2, left 1. Let's make our V nice and long. Arrows on both ends. Okay, I'm just going to skip number 6. All right, so now down below, I've got the pictures drawn, and I want to write the equation. So it's flip-flop of what we see here. Here we had the equation and drew the picture. Here we've got the picture, and we're going to write the equation. Okay? So we need to know how the vertex got here. So instead of being at 0, 0, how did it get here? It went left 4. Did it go up or down any? Nope. Okay, so to make a graph go left or right, does that go inside or outside? Inside. Don't forget your x in there. And what will make it go left 4? Plus 4. Now, all of these graphs, they're kind of hard to see because they're really tiny. These graphs either have a slope of 1 or -1. So do you think the slope is a positive 1 or a -1 here? A positive 1 because it's up 1, right 1, up 1, right 1, up 1, right 1. Remember, slope is positive if the graph opens up, but none of these have a slope of 2 or a slope of 4 or a slope of -3. And I'm just telling you that because the pictures are kind of hard to see. Okay, so the slope will either be a positive 1 or a -1 on all of these. And same thing with the problems on the assignment. All right, number 2. Let's see. How did the vertex get here from 0, 0? It went right 8. Did it go up or down? Nope, it's just sitting here at the right 8. Okay, so to make something go right, does that go inside or outside? It goes inside, so don't forget your little x. Now what's going to make it go right? A -8. And is this slope a positive or a negative? Positive. Okay, so we'll just keep it the way it is. All right, looking at number 3. How did the vertex get up here from 0, 0? It went up 5. Did it go left or right any? Nope. Okay, so if you want a graph to go left or right, up 5, would you put that on the inside or the outside? The outside. So to make it go up 5, it's going to have a +5 in the back. And then inside, we'll just have the x. We won't have anything else in there with it because it didn't go left or right. Now, is the slope positive or negative? Negative. Since the graph is opening down, the slope is negative. So I'm going to add a little negative right here. And that's my equation. Okay, let's just jump to 5. So looking at number 5. So instead of the vertex being here at 0, 0, it's here. How did it get there? It went right 3 and up 4. Right 3 and up 4. All right, so now we need to write the equation. All right, so let's get our x in here. To make it go right 3, that's going to be inside or outside? Inside, and it's going to say -3. To make it go up 4, that's the outside, and it's going to say +4. Is the slope positive or negative? Positive. All right, so I'm done. Okay, looking at 6. How did the vertex get here? From 0, 0, it went left 5 and down 3, it looks like. So left 5, down 3. So left 5 and down 3. All right, so let's try to write our equation. Let's go ahead and get that x in there. So to make it go left 5, inside or outside? Inside, what's it going to say? +5. And to make it go down 3, in the back with a -3. Is this slope positive or negative? Negative. Anytime the graph opens down, the slope is negative. So I need to put a little negative in front of that. And that's that lesson.